Okay, so this is up close. We're really looking microscopically. This would be your afferent arteriole. The red is your glomerulus. The flesh-colored, the layer is the visceral layer of Bowman's capsule. And then you have the parietal layer of Bowman's capsule. The visceral layer of Bowman's capsule is made up of cells, which the blue is showing the nuclei of the cell. Each individual cell is called a podocyte, and they have these tiny little feet called pedicels, and the adjacent pedicels are what make the filtration slits. So the fluid in the blood that is able to move through the pedicels, it enters between the visceral and parietal space, and it's called filtrate. Okay, a lot of what's in the blood does not leave, especially big things like red blood cells, white blood cells, plasma proteins. Those will stay in the glomerulus and they will exit out through the efferent arteriole. Okay, in the afferent arteriole, we have these specialized cells called juxtaglomerular cells or granular cells. And these are going to communicate with these cells here. This is a section off the distal convoluted tubule, which comes really close to the afferent arteriole again, where the cells get tall and they're side by side. This is called the macula densa. So the macula densa cells and the juxtaglomerular or JG cells together communicate and make what we call the juxtaglomerular apparatus. The communicating of these cells allows us to regulate our blood volume, therefore regulating blood pressure. Exiting filtrate, once it enters the space, is forced through the proximal convoluted tubule. You will notice here the proximal convoluted tubule shows microvilli. This is a big difference you can always see. Proximal convoluted tubule has villi, loop of Henle, and distal do not. So you have more surface area here for increased reabsorption.